The silent language of stars. Expanded version. For millennia, humans have been captivated by the night sky, with its infinite stars scattered across the dark expanse. The night sky has been the backdrop to our dreams, the setting for our deepest thoughts, and the silent companion to our desires for knowledge. Since time immemorial, people have gazed upward with awe, believing that these stars held answers to the fundamental questions of our existence. From ancient astronomers who charted their positions to modern astrophysicists who peer through the lenses of powerful telescopes, the stars have remained the most universal of human fascination. However, the true story of the stars is not as simple as it may appear. The twinkling lights above us are not just beautiful dots of light against a velvet sky. They are powerful cosmic engines born in the fiery depths of interstellar space, existing in cycles of birth, transformation, destruction, and rebirth. These magnificent celestial bodies hold the secrets of the universe within them. They speak to us in a language older than humanity itself, revealing their stories through light, energy, and gravity. Stars are not merely beautiful fixtures of the cosmos. They are the originators of life, the architects of galaxies, and the ultimate force shaping the universe. The story of each star is a complex journey, spanning billions of years and often culminating in explosive deaths that send ripples across the cosmos. Through the incredible forces of gravity, nuclear fusion, and time itself, stars create the very building blocks of life, such as carbon, oxygen, nitrogen, and iron, elements necessary for the existence of planets, life forms, and even us. The cosmic nursery. How stars are born. The birth of a star begins in one of the most beautiful and violent places in the universe, a nebula. Nebulae, vast clouds of gas and dust, are the cosmic nurseries where new stars are formed. These clouds are composed primarily of hydrogen, the most abundant element in the universe. Hydrogen atoms, influenced by gravitational forces, begin to clump together, forming dense regions within the nebula. Over millions of years, gravity pulls these regions together, causing them to collapse inward. The collapse increases the temperature and pressure at the core, eventually initiating nuclear fusion. Nuclear fusion occurs when hydrogen atoms fuse together to form helium, a process that releases an enormous amount of energy. This energy is what powers the star, allowing it to shine for millions to billions of years. The process of nuclear fusion also generates a powerful outward pressure that counteracts the inward pull of gravity, creating equilibrium within the star. This is when a star becomes a stable, shining body in the sky. The first stages of star formation are not peaceful. The collapsing cloud of gas and dust creates intense shockwaves that cause the surrounding material to heat up and radiate brightly. The gas surrounding the young star is expelled, forming a nebula, a cloud of gas and dust that often glows with the radiation emitted by the star at its core. This glowing nebula is known as an emission nebula. As the star continues to form, it begins to emit powerful solar winds that shape and disrupt the surrounding environment. Stars are born in stellar nurseries, where the very process of their creation is accompanied by intense bursts of energy and high-energy radiation. These newly born stars are often surrounded by swirling clouds of gas, particles, and intense radiation, which can have profound effects on their environments. Yet, despite these chaotic beginnings, the star eventually enters its stable phase, the main sequence. The main sequence, the heart of a star's life. Once a star is born, it enters the most significant phase of its life, the main sequence. This is the stage that lasts for the majority of a star's existence. During the main sequence phase, a star continuously fuses hydrogen into helium in its core, producing energy in the form of light and heat. The energy released during fusion creates an outward pressure that balances the inward pull of gravity. This equilibrium ensures the star remains stable for billions of years. Stars like our Sun spend approximately 90% of their life in this phase. The Sun, which is a medium-sized star, has been in the main sequence phase for approximately 4.6 billion years and will remain there for another 5 billion years. During this time, the Sun's energy output is relatively steady, providing the necessary warmth and light for life on Earth. However, not all stars are the same. Stars come in a wide range of sizes and masses, and these differences play a significant role in determining how long they remain in the main sequence and what happens to them when they leave it. Smaller stars, such as red dwarfs, burn their fuel more slowly and can remain in the main sequence for tens of billions of years. In contrast, massive stars burn through their fuel much more quickly, often consuming their hydrogen in just a few million years. As these stars age, their cores become increasingly unstable, and they will eventually leave the main sequence to evolve into red giants or supergiants. Red giants and supergiants, a final transformation. When a star exhausts the hydrogen in its core, it can no longer maintain the same rate of fusion. As a result, the core contracts due to gravity, causing an increase in temperature, while the outer layers of the star expand. This process transforms the star into a red giant or supergiant, depending on its initial mass. Red giants and supergiants are enormous, often many times larger than the Sun. As they expand, they can engulf nearby planets. In the case of our Sun, in about 5 billion years, it will expand into a red giant, potentially swallowing the Earth. As the outer layers of the star expand, they lose mass, forming planetary nebulae that enrich the surrounding interstellar medium with heavy elements such as carbon, oxygen, and nitrogen. These elements are crucial for the formation of new stars and planets in the future. For more massive stars, the process of fusion continues beyond hydrogen and helium. The star will begin to fuse heavier elements, such as carbon, oxygen, and silicon. When the core runs out of fusion fuel, the star will undergo a dramatic collapse, leading to a catastrophic explosion known as a supernova. Supernovae, the explosive death of a star. A supernova is the explosive death of a massive star. When a star with a mass greater than 8 times that of the Sun exhausts its nuclear fuel, its core collapses under the force of gravity. The temperature inside the core rises dramatically, causing the outer layers of the star to explode outward at incredibly high speeds. The explosion releases an enormous amount of energy, often outshining entire galaxies for a brief period. Supernovae are not only dramatic events, they are essential for the creation of the elements that make up everything we see in the universe. The extreme temperatures and pressures inside a supernova allow for the creation of heavier elements, such as iron, nickel, and even gold. These elements are then scattered across the cosmos, enriching the interstellar medium and providing the building blocks for future stars and planets. Without supernovae, the elements necessary for life would not exist. After a supernova, the remnant core of the star may collapse into a neutron star or a black hole, depending on the mass of the original star. Neutron stars are incredibly dense objects, where the mass of a star is compressed into a small, incredibly dense object only a few kilometers in diameter. The gravity near a neutron star is so intense that it distorts space-time and can even slow down time itself. If the remaining mass of the core is sufficiently large, it will collapse further into a black hole. Black holes are regions of space where gravity is so strong that not even light can escape. These cosmic monsters have a profound effect on the space around them, bending light and warping the fabric of space-time. The point of no return around a black hole is known as the event horizon, and anything that crosses this boundary is inevitably pulled into the black hole, never to escape. The legacy of stars. The creation of life. Even as stars die in violent explosions, their legacy lives on. The elements that are created in stars and released in supernovae are essential to the formation of planets and life itself. The iron in our blood, the oxygen we breathe, and the carbon that forms the foundation of our bodies were all formed in the hearts of stars. The death of stars fuels the creation of new stars, galaxies, and life forms. In this way, stars are the architects of life, seeding the universe with the building blocks of existence. The Earth itself is the result of stars' actions. The Sun, born from a cloud of gas and dust in the Milky Way, provided the energy and warmth necessary for life to flourish. The elements that make up the Earth and all living things were once created inside ancient stars and distributed across the cosmos in the wake of their deaths. Stars, timeless messengers. Stars have a timeless legacy. As they burn, they release light that travels across the vast reaches of space. The light we see from stars today has traveled millions, even billions of years to reach us. In a sense, when we look up at the stars, we are not just gazing at distant lights, but are also peering into the past of the universe. The stars are cosmic messengers, carrying with them the history of the cosmos from the beginning of time to the present day. Even as the universe continues to evolve, stars will continue to play a crucial role in the creation of new galaxies, planets, and life. They will continue to shine, explode, and give birth to new generations of stars, ensuring that the cycle of creation and destruction never ends. The stars remind us that we are part of something much larger, a vast and interconnected universe where life, death, and rebirth are inextricably linked. They offer us a glimpse into the past, the present, and the future of the cosmos. The stars are not just distant objects in the sky. They are the silent witnesses to the story of the universe, and their light will continue to shine long after we are gone.